So today we have, again, two speakers before we break for lunch. And we're going to be focusing on both XRF and the analysis of more modern paintings. So I'd like to first welcome Dr. Jennifer Mass, who I think needs little introduction, but I will do so anyway. She received a PhD in inorganic chemistry from Cornell University with a concentration in materials engineering. And she was then awarded a Mellon Fellowship at the Sherman Fairchild Center for Objects Conservation at the Met, and taught for 3 years at the Buffalo Art Conservation MA program. She is currently laboratory director and senior scientist of the Winterthur Scientific Research Analysis Lab, and is also a faculty member of the University of Delaware and the Winterthur program in art conservation. She conducts research on the degradation mechanisms of artist materials, which I'm sure you're familiar with, on synchrotron-based materials, methods such as the development of confocal X-ray fluorescence microscopy for the non-destructive depth profiling of paintings. She has published many articles, and in fact, this is her book, which will be in the prize draw. She has recently co-edited a volume on handheld applications in art and archaeology, this here. And she is also co-organizing the conference that Francesca Casadio mentioned yesterday, the Gordon Research Conference on Scientific Methods and Cultural Heritage. So if you want, you can ask her and Francesca about that later. But first, I'd like to welcome Jennifer to talk today about XRF applications.
Thank you so much, Austin, and to all of the organizers for having me here. This was perhaps one of the most difficult presentations I've ever put together. You can see I've got a lot of paintings to cover. I've got a lot of data. I've got a lot of people. So we were very, very fortunate. I'd like to point out Eric Uffelman from Washington and Lee and Barbara Buckley and I from the Barnes Foundation to have the Lenfest Foundation not only support our travel to research these paintings, but also to allow us to include chemistry undergraduates in this research. And I'm thrilled to have Alyssa Hull, double major in chemistry and art conservation from University of Delaware in the audience today. So I'd like to start out by saying that I don't belong here at all. I love microanalysis. And so trying to put this presentation together, it was like doing it with two hands tied behind my back because we have gigabytes worth of microanalysis data on these paintings, and I'm not going to show you any of it. I'm going to strictly talk about the standoff methods that we could use to understand these works. So for those of you in the past 2 days that have shown cross-sections, you know who you are. You were cheating, and I will not be. Okay, so here we have what I think you will agree are two very closely related sets of work. Edvard Munch's The Scream, 4 different variations from 1893 to 1910, and Henri Matisse's The Joy of Life, all done between 1905 and 1906. In terms of why we chose these works to focus on for our standoff analytical method comparison, well, we had problems with the cadmium yellow alteration in 2 of these works, this one and in this one. And so we wanted to understand how cadmium yellow alteration was affecting the closely related works, and to do so in the most standoff and non-destructive way possible. And so we were fortunate to have the opportunity to very closely examine this work in Copenhagen, this work in San Francisco, this work in Oslo, which I will not talk about because we only have microanalysis material, and then this work where we have the holistic analysis methods. Okay, so this is the big question. Do we have cadmium yellow alteration in these closely related works? And I've listed our protocol here. And so, as you've heard many times before at this conference, visible light examination can be critical to understanding the paintings. Ultraviolet-induced visible fluorescence, really a workhorse for our field. And also, we included ultraviolet-induced infrared fluorescence, 2 different types of X-ray fluorescence, and then in the case of the monumental barns, we did some multi-spectral imaging with John Delaney and René Delary. Okay, so in terms of really wanting to understand what the possibilities and limitations of these different techniques are, the reason that we felt this was so critical is that we needed to really identify the use of cadmium pigments in turn of the 20th century paintings. And the big concern is that currently photooxidative degradation of these pigments irreversibly changes not only their chemical and physical properties, but also it greatly affects the appearance of the paintings. And so these are the methods that I listed that we're going to be looking at. And what we really wanted to know is how efficient are they? How comprehensive are they? And are they what I called reliably discriminatory? And what I mean by that is, are we able to use them to say, these cadmium pigments have altered, but these other cadmium pigments are intact? And what we found is that several of them, in fact, did depend on the state of preservation of the cadmium pigment being used. Okay, so the first step was visible light examination. This is Barbara Buckley, the head of conservation at the Barnes Foundation, who does not like having her picture taken. So I really had to sneak these in there. And so here is Barbara in Copenhagen looking at the SMK study, and in San Francisco looking at the SF-MoMA study. And this research all started out with the monumental version of The Joy of Life, which was painted by Matisse in the winter of 1905 to 1906 and has been in the Barnes Foundation since 1922. And you can see that its condition, unfortunately, today is that it does have regions of extensive discoloration. And I'm highlighting just one of them here. Underneath the central reclining figures, you can see that, well, we will see what was originally warm yellow is now kind of a dirty ivory color. And this gives you a sense of the scale of the work for those of you that haven't seen it in person. So in terms of our study of the work, we really focused on the three areas that had the greatest degree of alteration. And that is the upper left corner where we have this darkening to almost an ochre color. And then the lemons in the tree, which have kind of this dirty ivory alteration crust that's grown on them. And then under the central reclining figures, kind of this, again, dirty ivory color that we're seeing in a region that used to be bright yellow. You can see some of the original bright yellow there. And in addition to the discoloration and the fading, we also have chalking, flaking, and spalling. So this is very much a physical phenomenon as well as a chemical phenomenon. And in our handheld XRF survey of this work, we were able to confirm that what we were seeing was not the chrome yellow degradation that's been talked about earlier in this conference, nor the zinc yellow alteration that Francesca has written so much about, but instead we did have the cadmium yellow alteration in all three areas that had the changes. So how can we be comprehensive in our study of monumental painting? Well, we started out with pXRF and quickly figured out that this was going to be a very challenging way to go. And so then we turned to ultraviolet-induced fluorescence in the visible. And what I'm showing is just this tiny region in between these two embracing figures here. And what you could see is that in visible light, the center of the daisies in ultraviolet light fluoresces this bright orange color. And so we wanted to know first what we were looking at with this orange fluorescence of cadmium yellow pigments. Much has been written about this, but it's not been, I think, as well understood as it could be. And Austin and collaborators did an excellent paper on this topic this year. And they noted that the orange fluorescence is caused in large part by the trace impurities that are present in the cadmium sulfide lattice. And unfortunately, these trace impurities can be below the minimum detection limit of X-ray fluorescence and SEM EDS. And so they're going to be very difficult to identify in the museum laboratory. And what they do is they form deep trap states in what is a direct band gap semiconductor. And I know that a lot of my former graduate students are in the room today, and I hope they don't run screaming for the exits if I just take a moment to say that when we have a direct band gap semiconductor, what we're looking at is the valence band that's filled with the electrons conduction band that's only partially filled with electrons, and then the deep trap states are going to be in the middle of the valence band and the conduction band. And so they are going to give the semiconductor the electronic properties that results in the characteristic fluorescence that occurs in the orange through the near IR. The maximum for cadmium sulfide, the yellow pigment, occurs at about 750 nanometers, and for the sulfoselenides, it's a little bit higher, around 800 nanometers. But really, the takeaway lesson from this slide is that if you have completely pure cadmium sulfide, it will not fluoresce, nor will cadmium sulfide fluoresce from all manufacturers. So here is a comparison of detail from the monumental Barnes painting in visible light, the ultraviolet-induced infrared, and we're using a 715 nanometer cutoff filter on our camera, and then the ultraviolet-induced visible image. And what I really wanted to point out here is how limited the ultraviolet-induced visible fluorescence is. So we see the characteristic orange fluorescence only where there's the yellow color left in the cadmium pigment. And so this is all altered cadmium pigment, all surrounding this little sort of cluster of grass here. And notice that none of it really fluoresces in the orange. And we think what's going on here is that the alteration crust is thick enough that what we have in this layer, and actually this is a small amount of microanalysis information, is almost 100% cadmium sulfate and cadmium carbonate. And so the photo alteration has destroyed the semiconductor structure that's responsible for the orange fluorescence. And so we can see that this orange fluorescence is not going to be a comprehensive way to identify cadmium pigments, but it is going to help us to identify altered cadmium pigments that are in the beginning stages of their alteration. Okay, so this is the second region on the monumental landscape. There's a crouching figure here, perhaps male, perhaps female, hard to say. There's another figure standing behind him. And so when we look at the close-up, we can see there's all this alteration, this fading of the cadmium yellow foreground here. In the ultraviolet-induced visible image, we only have a very small amount of orange fluorescence. And again, that's likely where the semiconductor structure is still intact, and so we have those deep trap states still being active. And in the ultraviolet-induced infrared, we really don't get much information at all. So how can we comprehensively image where we have the use of the cadmium sulfides and sulfoselenides? Well, it turns out with the multi-spectral imaging, John Delaney was able to produce these false color emission maps that are shown here for two different regions of the painting. And so the excitation was in the blue-green. I've given the wavelength range here. And the emission was recorded at 3 different wavelengths. And now you can really truly see Matisse's original intent in terms of his use of cadmium pigments in this work. And one example is the halo over the woman with the black hair. You can see just a single yellow brushstroke here, but originally there were 2 yellow brushstrokes, and the top one has faded away. And likewise, if you look at the dancers in a circle in the background, what you can see is that a lot of their outlines were done in cadmium pigments, which was very challenging to determine with X-ray fluorescence. And so we found this to be both an efficient and comprehensive technique. So now we're going to move to Copenhagen to take a look at a 1905 study for the monumental Barnes version. And I wanted to point out that this was an early experiment from Matisse done in a fishing village in the south of France. And it's really one of the more radical works of his that came out of this period, because he's actually really transforming the notion of what a landscape can be, not only in terms of the colors that he uses, but also his execution of the work and his composition. And so, for example, he uses the ground quite heavily in his composition and leaves it showing through in a number of different places on the painting. And this is the same painting twice, just under 2 different lighting conditions. So what we really wanted to know about this work is what is its current condition, given the condition that we see in the monumental work. What palette did Matisse use? How did it relate to the monumental work? And what we could see, first of all, is the paint surface is actually pretty terrific. It's quite glossy and quite intact, and you get a sense of that here. And there's no evidence of the chalking and discoloration that we're seeing in the Barnes version. And what we see also, this region is a close-up of the central foreground here, mixing of dark yellow paint with a white, which we don't see in the monumental version too. And I think actually is quite critical to why this one is in such good condition. We'll see. And here's another visible light comparison of the Copenhagen version now next to the Philadelphia version. And you can see where the cadmium yellow is substantially altered in these regions, and yet it's in excellent condition in the Copenhagen version. And then in the upper left corner, the foliage that's both in some ways darkened and faded in the Philadelphia Barnes version, we can see is in excellent condition in the Copenhagen version. And now the central foreground again, you can see in the Barnes version that we do have this fading all under the central figures, and spalling as well, where the alteration crust has flaked away to reveal the paint that's in fairly good condition underneath, so you can get a sense of the original palette. And we can see beyond the addition of the figures in the final work that Matisse did make several other changes. And so, for example, the trunk of this tree is blue here, while it's green in the final work, and he did use green in the background foliage here, while it's yellow in the final work. And we can see that the impasto of the paint is intact. It's not really, you couldn't really call it high impasto, but there's a fair amount of impasto here, and while those areas are flaking in the Barnes version, we don't see any chalking, any flaking or spalling, and no presence of alteration crusts. And actually, some of the best images that we could get of how glossy and intact the paint surface was in the XRF. And so you can see this is an Artax image that shows you nicely the good condition of the painting. And that brings us to the XRF analysis of this particular work. This was done with Anna Vila at CATS, so the Center for Art, Technological Studies, and Conservation at the SMK, and we were using rhodium tube Artax. And so what we were able to see in the foreground of the work was an incredibly large amount of zinc, and so we do in fact have what appears to be zinc white that's mixed with yellow pigment in order to create the warm yellow in the foreground rather than cadmium yellow light. And the colormen of the period actually started warning about the instability of cadmium yellow light starting in the last decades of the 19th century. And so the fact that he's using a darker cadmium here definitely contributes to its state of preservation. And then we can see, not only confirm that we do in fact have cadmium yellow in the foreground, but also if you look at the inversion of the heights of the lead L alpha and L beta peak, that suggests that we have a buried lead layer, that we've got a lead white ground, which is certainly appropriate to the period. And we have a very small amount of chromium, and at that level it could just be a dirty brush phenomenon. And then when we look up in the foliage in the upper left corner, what we see is that we do again have cadmium yellow, and so Matisse seems to be setting up the template here that he then follows in the subsequent three works. But we do also see a small amount of chromium in this region. And I also wanted to point out that you really want to look at the cadmium L lines when you're trying to make a determination of cadmium and you have a lead ground paint, because when you look at, these are our original lead L alpha and L beta lines, but then we have some peaks or double photon counting events for the L lines. So this is 2 times the lead L alpha energy, we have a peak, 2 times the lead L beta, and then right where lead L alpha plus lead L beta is, that would be our cadmium K line, and so you really need to use the L line for identification. When we look at the dark fruits of the tree that are cadmium yellow in the monumental version, we also see a fair amount of cadmium, and it's likely here that the chromium is actually coming from a chrome green that's underneath the cadmium yellow fruit, but this is a question that can't really be answered with the XRF. So we do start to see some divergence from the Barnes version, though. When we look in the region that corresponds to the dancers in the circle, all of this sort of cool yellow around the dancers is actually chrome yellow. But when we look at the Copenhagen version, we see that it's actually cadmium yellow. And so we don't have a 100% correspondence between the map of the pigments in the two works. And that turns out to be true in the foreground as well, that Matisse is using a chrome yellow in the foreground here, while he's using a cadmium yellow in the foreground here. And when we look at ultraviolet-induced visible fluorescence, what we see is no evidence of the characteristic orange fluorescence that's been ascribed to altered cadmium yellow at all. And this is perhaps consistent with the good condition of the paint that we see in our visual examination. And so perhaps we have no trace impurities in the cadmium sulfide lattice due to photo alteration. And as a result, we don't have any deep trap states in the semiconductor structure that cause the orange fluorescence. And it's also quite likely that Matisse was using a different source of cadmium yellow in the south of France versus the monumental work, which was painted in Paris. And the infrared fluorescence shows us just the same thing. We really have no activity. And so, again, probably due to the absence of any photo alteration and also likely due to the use of a different cadmium yellow source. Okay, so I couldn't resist putting in some data from the San Francisco version as well. And so this is an oil study for the monumental landscape. You can see it's much closer. The figures have been added now. But it's about a quarter the size of the monumental landscape, and it has some neo-impressionist features that you don't really see in the Copenhagen version, which are kind of interesting. The daubs of color under the central figures, for example. Okay, so on first glance, if we compare this to the Barnes painting, what we see is that overall the condition looks excellent, both in terms of the surface of the paint and the retention of the color. And so in condition, it's really quite a bit closer to the SMK version than to the Philadelphia version. And this is Paula de Cristofaro, the paintings conservator at SF MoMA, who worked with us. When you start to get up closer, though, you can see some evidence of what appears to be the drying out that we do see as kind of a precursor to full-on alteration of the cadmium sulfide yellow. And it's a little bit difficult to see in this slide, but a network of cracks is starting to develop in this particular brushstroke. And I think you can see it much better in this next slide. And so we have this somewhat orthogonal network of cracks, and there are a number of different mechanisms that can cause that type of cracking, but cadmium alteration has been observed to be one of them. And so that was of interest. And also the brushstroke next to it, you can see we've got some surface accretions, perhaps they're residual varnish, or perhaps we're looking at the beginning of photo alteration products. And I also wanted to point out this particular brushstroke, we're above the embracing green figures here. We can see has some evidence of alteration. It looks like it's starting to develop an alteration crust. And you can see that a little better at higher magnification too, that we do have a slight discoloration just in that one brushstroke. The foliage in the upper left corner, though, is in excellent condition. There's really no evidence of any alteration at all. And likewise for the lemons in the tree, we can see the alteration crusts on the Barnes painting, and they're completely absent in the San Francisco painting. Now it turns out that ultraviolet-induced visible fluorescence, when you have what appears to be incipient photo alteration, can be extremely helpful. And so you can see this one brushstroke that we had questions about, and really it's changing visibly, only quite subtly from the surrounding brushstrokes. It lights up quite dramatically when we look at it in ultraviolet light. And so since it's quite unlikely that Matisse used two different sources of cadmium yellow, for example, for these brushstrokes versus this brushstroke, probably what we are looking at here is a way to use ultraviolet fluorescence in order to point out incipient photodegradation. And then here's a larger view of the painting, and you can see once again just that individual brushstroke is lit up with the characteristic orange color. And the same thing is true under the central reclining figures. That one brushstroke that had the network of cracks in it, we can see also shows up with the orange fluorescence under ultraviolet light. And then when we do the ultraviolet-induced infrared fluorescence as well, you can see not only how brightly the altered brushstrokes light up, but also you get information about Matisse's use of cadmium pigments in general. And so this really gave us some hope that these rapid and inexpensive, portable and accessible imaging techniques can be quite useful in terms of screening for cadmium alteration in its very early stages. And I'm not going to show any X-ray fluorescence data from this work because the analysis of this data is still very much ongoing. This is all very late breaking. So instead, I'm going to switch over to Oslo to talk about the Scream. The Scream is not one painting, but actually 4 different paintings. And so we've got the 2 mixed media works, and I want to point out that all 4 of them are actually painted on cardboard. And so in addition to the mixed media works, we also have these two pastels on cardboard as well. This one has been in the news recently since it was sold at Sotheby's in 2012. And this one has been in the news recently as well because of it being stolen in 2004 and then returned in 2006. And you can see the water-related damage that it occurred as a result of that little adventure that it went on. So we wanted to focus on this particular work in terms of understanding the use of cadmium yellows better because the photo alteration has been observed in this work, while this one remains in excellent condition. So we had three different problem areas: a brushstroke in the sky that used to be bright yellow and is now altered to a white color, and that's a virtual reconstruction. And then in the water as well, we have, again, not really a high impasto, but kind of a medium impasto area that's spalling. And then even in the neck of the central figure, these brushstrokes that appear white are actually painted with a cadmium pigment. So this is a comparison between the visible light image and the visible fluorescence from the ultraviolet. And what you can see is that the orange fluorescence is observed in many locations, but we also have brown fluorescence observed in many locations. And so if you look at the sky, we've got extensive use of cadmium yellows and oranges, and some of them fluoresce orange and others of them fluoresce brown. And previous authors have suggested that the brown fluorescence is evidence of intact cadmium yellow that's in good condition, and we're not yet sure if that's the case for this particular painting. So here's an example of some of the XRF analysis that we did in the kind of orange highlight on the railing here, where we did in fact see the use of cadmium yellow, and we can see not only the orange fluorescence, but also the brown fluorescence in that area. And I also wanted to point out that the ultraviolet-induced infrared fluorescence points out very nicely the use of cadmium in the water, where it can be difficult to see because it's faded in some areas. And then in the visibly unaltered cadmium yellow, this is cadmium yellow here that's actually mixed with vermilion. So there's the cadmium in the XRF, and there's the mercury. We see once again both this mixed orange and brown fluorescence that I think really deserves further study. And interestingly enough, in the altered brushstroke that now appears white, we don't see any fluorescence in the ultraviolet whatsoever. So once again, this gives you a sense of the more advanced the alteration is, the further away you're getting from that original semiconductor structure that's responsible because of its electronic structure for the orange fluorescence. So when you have this full alteration, you aren't able to image the pigment using ultraviolet light. Okay, and then one rather unique result in the case of the central figure in the screen, where we're able to see altered cadmium yellow that's very readily visible, these two brushstrokes here in the infrared fluorescence image, but it doesn't show up at all really in the visible light fluorescence image. And so it really shows that this UV-induced infrared fluorescence, which hasn't been used very much in our field, does have some great utility for understanding these types of problems. So in terms of what we can conclude from all of this work, for the visible light examination, it's certainly very useful in the case of advanced alteration, like we see in the Philadelphia work. It's somewhat minimally useful for incipient alteration, and of course it's not comprehensive. In the case of the ultraviolet-induced fluorescence, what we see is that in fact it's misleading in the case of the advanced alteration, like we see in the Philadelphia Matisse, and also in the Oslo version of the screen. But it certainly does have potential for incipient alteration, as we see in the San Francisco work. In the case of the ultraviolet-induced infrared fluorescence, we were certainly able to identify the altered cadmium yellow in one case where we couldn't identify it by any of the other methods that we were using, but we have seen that it's not comprehensive, particularly in the Philadelphia Matisse. And then in the case of multispectral imaging, it certainly was comprehensive in terms of identifying all of the cadmium-containing pigments in the Barnes painting, and it identified them independent of condition, for better or worse. Sometimes we really want to know about condition. And I think that with more extensive multispectral imaging, we likely will be able to say more about condition using this technique, but not with what we've done so far. And then pXRF is, of course, an excellent way to identify the cadmium-containing pigments when no characteristic fluorescence is observed at all. But we found it very challenging to be comprehensive using this technique on a monumental work. And unfortunately, it gives us no indication of the state of preservation, which SEM-EDS likely would be helpful with. And the problem is that we have the lead ground, and so the lead M line is overlapping with the sulfur K line, and so we can't look at the ratio of cadmium to sulfur, which changes as the photo alteration occurs. So that's an area where you really would need to sample. And finally, I would like to thank all of you for your attention, all of the many, many people that gave their time and expertise to this project, and in particular thank the Lenfest Foundation that made it possible for so many of us to participate.
That was really brilliant, thank you, Jennifer. I'm sure some people have questions besides me, so please. We have a couple of minutes for questions before we move, because we started a little bit later. So, I see one from Francesca in the back.
Jennifer, it's a fascinating presentation. I actually couldn't help but noticing, I mean, the whole issue of the fluorescence of the cadmiums is very interesting, but I couldn't help but noticing that also in the other studies, the flesh tones are much more pink and purples than in the Barnes painting. And from your analysis, do you have indication that there's red lakes mixed in those flesh tones, and might there have been fading of those?
That's an excellent question. And when we did collaborate with what was then ICN, what is now RCE, and did some examination of the flesh tones, what we found was purpurine only, not alizarin, which is kind of the opposite of what you would expect if you had initially started with a madder lake and then had photo alterations. So, but at the time period in which this was painting, it could have been that the pigment was actually pure purpurine to start with, synthetic purpurine. And I suspect that we are having alteration of those pigments as well. And maybe I'll spend the next 6 years trying to figure that out.
I have a question about the strange individual brushstrokes which seem to be altering. Do you, just as an idea, from the XRF, do you think there's some different pigment mixture which could be affecting the cadmiums? I mean, other pigments inside there, which, because otherwise, how would we explain that?
That's a terrific question, and it is really a challenge to explain, especially when we do feel like Matisse was not changing pigment sources in that one brushstroke. And certainly we know that as cadmium yellow alters, it does start to interact with the other pigments that surround it. And so it's entirely possible that if we had more lead white, for example, mixed into that one brushstroke, that we could see a different degree of alteration there. So I think you're on the right track.
Do you have any more questions before we move on? I'm sure you'll have questions for Jennifer in the break. I'm really happy for that talk. That was great. Thank you very much.